Can you hear me? Right. My name is Shay Keinan, and I'm here to talk to you about ReactVR. So who the heck am I, and why am I talking about VR or about 3D? It all started 3 years ago. I worked at Autodesk in a small team who developed some 3D experiences for different customers, clients, such as New Balance, Adidas, Under Armour. We did stuff for Caterpillar or BMW for the Mini Cooper, and even for NASA. And I needed to integrate Three.js into React on my own before we had ReactVR or before we had the library React 3, which I don't recommend at all. And nowadays, I work at 500 Tech, mainly with React and React Native. I'm doing all sorts of projects. I provide consulting services to companies, and I teach various courses, such as data visualizations, advanced React, or even CSS and advanced CSS and animations. I also lead the React Israel meetup community with more than 2,500 members. So if you are around, I am more than happy to invite you to our monthly meetup session. So today I'm here to talk to you about ReactVR. We will start with the basic concepts of virtual reality. We will learn how to get started with ReactVR, and we will learn also a new approach for integrating 3D views into ReactJS. So by the end of this talk, you will know when to use ReactVR and how to do it, and how to get started with Three.js and develop 3D experiences in your web browsers. Virtual reality is being used in many industries. Besides games, VR is used in fields such as medicine, education, movies, architecture, travel, military preparation, retail, and many, many more. Because of its ability to completely immerse you in a scene, the possibilities are endless. It all goes back to something called lucid dreaming. A lucid dream is a dream in which the dreamer is aware of dreaming and can do anything, even fly or learn Kung Fu, like the Matrix. The first known mention of virtual reality was in the ancient Sanskrit text of Mandyuka Upanishad around 500 BC. Then, around 415 BC, St. Augustine presented to us the first well-known report of lucid dreaming. He shared the story of a friend who dreamed he was hanging out with a guy in heaven, and the guy kept reminding him that he was actually asleep. Then, the first published mention of lucid dreaming and its scientific potential was by this guy with the long name in 1867, and he wrote a book called Dreams and the Means of Directing Them. In 1838, Charles Wheatstone invented the stereoscope. He found that if you put two slightly different images next to each other, the brain can turn them into a 3D image. This brought up something called virtual tourism. For the first time, people could actually see and experience places they have only dreamed about. In 1935, Stanley Weinbaum released Pygmalion's Spectacles, a story about a pair of goggles that can let a person feel like they are in a fictional world. This is considered the first comprehensive model for virtual reality. For the next several decades, we got things like the Sensorama, the Ultimate Display, NASA's Virtual Visual Environment Display, Sega VR, and the Nintendo Virtual Boy. Finally, in 1987, Jaron Lanier invented the term virtual reality. And since then, we've had things like Google Cardboard, Google Daydream, and the Samsung Gear VR, all of which are very basic but affordable. Then we got the Oculus Rift, the HTC Vive, and the PlayStation VR that gives us a rich experience, but with an expensive price tag. Those devices require external computing power and external tracking sensors, and as a result, they are not portable. Computing systems of all sorts are getting smaller, cheaper, and much more efficient, and virtual reality is no different. A couple of standalone VR headsets will arrive this year, and they will be able to advance VR as a mainstream consumer technology. One example is the Oculus Go, announced at Oculus Connect, which is due to be released early this year with a reasonable price tag. I think it will be $200. The Go is going to offer a standalone experience, but without positional tracking, meaning that the user will always be in the center with a 360 degrees view. Oculus is also working on a second standalone VR, a VR headset codenamed Santa Cruz. It is going to offer positional tracking using on-headset trackers. The device also has 6 degrees of freedom, meaning it recognizes your hand movement and you can interact with objects within the scene. HTC has the same goal in mind and said that they are focusing all of their standalone energies on the Vive Focus that will also offer positional tracking and 6 degrees of freedom. Dozens of developers already building a lot of content for the Vive Focus, which could very well be the first standalone VR headset with those capabilities. These 3 headsets are a big step towards virtual reality becoming a true mainstream technology. So now, after understanding how it all started, we can talk about virtual reality concepts, things that we as developers must know if we want to build a virtual reality application. So what is virtual reality in a nutshell? Visual virtual reality is made up of 2 things: stereoscopic imaging and movement tracking. So let's look at these 2 images. Are they identical? They seem identical, but if we look closely, we can see some differences. I've highlighted one for you. You can see the figure on the right. So stereoscopic images are based on how the human brain works. It takes 2 images that show the same content, but from a slightly different point of view. The offset of these images corresponds to the distance between our eyes. This distance is called interpupillary distance, or IPD for short. In this way, we simulate the way we see the world naturally, and it gives us the perception of 3D depth. Headset lenses are an integral part of the virtual reality experience. Why do you use headset lenses? Because they position the images on the screen at the exact distance that they need to be in order to get the desired effect, the stereoscopic effect. But headset lenses are thick, and they cause a distortion. The square that you see on the left looks caved in through the lenses. The outcome looks something like what we see on the right. So to compensate for this, we give images that are rounded out. On the left, you can see a compensated image before the lenses, and on the right, this is the final desired image. So to sum up stereoscopic imaging by showing 2 slightly different images to each eye using special lenses, we get the effect of depth. Besides stereoscopic imaging, the second thing we need in order to complete the illusion of virtual space is to track the movement of our body. All VR devices track head movement so we can look around. Some devices, the more expensive ones, track body movement so we can move around, we can walk around the scene. Of course, the more tracking sensors that you have, the better the illusion of reality. Last year, Facebook announced the launch of ReactVR, a new JavaScript framework based on Three.js and React Native. ReactVR allows developers to build virtual reality experiences with the help of JavaScript. As the name implies, ReactVR uses the same concepts as Facebook's existing React framework. So just like with React for standard web apps, VR developers can now use the same declarative model to build their 360 degrees experiences. Just like in animation, VR apps need to be rendered at 60 frames per second, and this is something that React Native has already solved for us. It's important, again, to know that VR is based on React Native and Three.js, so most of the components that we use are React Native components, and the 3D rendering engine is the Three.js rendering engine. For those of you who are not familiar with Three.js, Three.js is a cross-browser JavaScript library used for displaying animated 3D graphics. Around 2008, Ricardo Cabello decided that it is too difficult to build those experiences using WebGL. So he wrote a JavaScript abstraction for that, and since then, this is the leading library for 3D experiences in web browsers. So let's look at some Three.js examples from the web. So we can create games or experiences or 3D maps, even movie trailers, everything in the browser, and it works in 60 frames per second, even on your mobile phones. So let's get started. We'll begin by installing a global tool called ReactVR CLI, just like Create React App or Create React Native App. ReactVR CLI is a generator for generating new ReactVR applications. So we're going to run ReactVR init welcome to VR, welcome to VR, the name of our project. We will move to this folder and run npm start, and then we will see the application on our browser. Facebook already created a very basic hello world application, and if everything is going well, you should see the following: a basic scene with a panoramic image of a room, and in front of us we can see a text component with the word hello. After the init, we get the following file structure. All the static assets are located at the static assets folder. So if we want to load 3D models, textures, images, or sounds, this is the right place. The entry point for our application is the index.vr.js file. And if we want to do some advanced VR configuration, we will go to the client.js file. So this is the entry point for our application. We have a basic React component that contains two children, pano for the panoramic image of the room, and text for the word hello. And in the bottom, we can see that we are registering the welcome to VR component, just like we do in React or in React Native. So let's begin building our own application, where we are going to build together an app that will present our solar system planets. You can check it out yourself on your mobile phones using this link. It's bit.ly/solardemo. And this is what the application is going to look like. We can see a planet with some text. And on our right, we can see a menu. A click on the menu button switches to another planet, another 3D model. There is some asteroids orbiting around the 3D model. And if we look to our left, there is some additional information about the planet. To know where to place objects and how to move around the scene, we need to be familiar with the coordinate system. So the coordinate system is the same as OpenGL coordinate system, meaning that y positive is up, and we use the right-hand rule for rotation, meaning that if this is y, the y-axis, this is a positive rotation, and this is a negative rotation, if you need to know how to move around the scene. We can apply different transformations on any component, just like we do with CSS. The syntax is a bit different than classic CSS, but should be familiar to those who code in React Native. So if I want to place an object anywhere other than 0, 0, 0, I will use translate. If I want to change its size, I will use scale. And if I want to rotate it along a certain axis, I will use rotate. Just like React Native, ReactVR provides a set of basic primitives used to construct user interface. This is a powerful feature of ReactVR. Developers can now use the same styling and layout system across Web, React Native, and ReactVR, which opens the doors to directly sharing layout styles across these platforms. So let's begin. Vue is the most fundamental component for building a user interface. Vue is a container that supports layout with Flexbox, style, and touch handling. Vue maps directly to the native Vue equivalent on whatever React Native is running on, whether that is a UI view, a div, Android view, etc. Vue is designed to be nested inside other views and can have 0 to many children of any type. Text is a simple React component for displaying text, also supports nesting and styling. And image, this is a React component for displaying different types of images. Keep in mind that you must manually specify the dimensions of your image. In ReactVR, image dimensions are specified in meters, not in pixels. And it is very difficult to predict the intended dimensions from the pixel width and height of the original image. So let's go back to our solar system application and add a pano component. What is a pano component? This is a sphere of 1,000 meters with a center located at the local transform origin Usually, it's 0, 0, 0. Panos are images projected onto a sphere that fully surrounds the viewer, and you can create pano-compatible images by using special 360 cameras, or nowadays using your mobile phones. CubeMap images are also supported in Pano. You can specify a source URL as an array of 6 individual images, 1 image for each side of the cube. So let's add a Pano component to our index.vr.js file. We need to provide an asset to the source property. We need to provide the image. Note that we are using a utility from ReactVR called asset. This allows us to load assets directly from the static assets folder I have showed you before. And another thing, again, the image that we are loading, it's not any JPEG. This is an image, a JPEG or a PNG that supports 3D. This is a panoramic image. So this is the image, and now let's look. It's a bit, you can't see it, but let's see how it looks like in 3D. Oh, thanks. We can see that the image surrounds us, and our sphere, the Pano, is the cosmos. Thanks. So that was the Pano component. Now let's talk about the Flexbox layout system. In ReactVR, we can lay out components in 3D using Flexbox, just like the web or just like React Native. The library used is CSS layout, and the syntax is more or less identical to the web Flexbox. As you can imagine, using Flexbox to lay out content on a 2D plane is not optimal for the 3D experience. So it's a common practice to lay out the content on a cylindrical plane, and this will give us a 2.5D feel. In our application, I created a menu to navigate between planets. This is our menu. It's basically a view that contains other views, 1 view per planet. And we can notice that there is a billboarding property. What is billboarding? It's a Boolean property for controlling the view rotation towards the screen, meaning that when billboarding is on, the view will always face the viewer. It will always face us. Let's see an example for that. Here we have 2 views. The one on the left is always facing us because billboarding is on. So this is our menu in 3D in ReactVR. Again, this is very, very simple. We have a view with 9 views inside, 1 for each planet. So we built a menu for navigating among the planets. Now we want to make it clickable. In VR, we interact with objects in a different way than the web or than your mobile phones. We don't necessarily click on something. It may be enough that we will look at an object for a significant amount of time in order to trigger an event. Other than looking, we can also press a controller in order to trigger a reaction. To make our scene interactable, we are going to use a component from ReactVR. His name is the VR button. This is a helper component that manages the interaction state machine. By default, a VR button has no appearance and will only act as a wrapper to capture events, but it can be styled in the same ways as a view. When pressing a button in our menu, we're going to store the planet ID under the current planet variable. So let's take a look at our menu again. And again, this is just React. Now, when we press on a button, we are updating the current planet variable. And as a result, we can see that the header is updating. And soon, we will also replace the 3D model. Next, I want to talk about loading models. There are many types of model formats out there: OBJ, STL, Collada, C3D. They may come with a built-in animation. They may come with a material or a texture. At the moment, ReactVR supports the wavefront OBJ file format only. So under the static assets folder, I have created 2 folders, one for models and one for textures. Textures are basically images, PNG, or JPEGs that wraps the 3D model, usually using UV mapping. ReactVR provides a component for loading models. Surprisingly, his name is model. So let's load Earth. Here is our planet declaration. And we can notice that there is a lit property. The lit property specifies if the model will be affected by lights or not. And the model's ability to define a style enables us to apply different transformations, such as scaling, rotating, and translating. And here is dynamic loading, not just Earth, but rather any planet according to the current planet variable. So here's the loaded model in front of us. And by changing the current planet variable, if we press on a navigation button, we can see that the 3D model is changing. To make our scene more interesting, we can add animations to objects and layouts. There are two ways to create animations in ReactVR, using the animated library or any third-party library for JavaScript animations, or manually with request animation frame. So this is an example of request animation frame. What I want to do here is rotate a planet. The rotate function in this example is called in a loop, hopefully at least 60 frames per second. And on each call, we are advancing the rotation by a certain delta. And this is the result. We can see that the planet is rotating. We did animation in 3D right now. And even if we click on a menu button, the new 3D model still rotates around itself in the same way. Now let's see an example of how to use the animated library for animations. So when a button is pressed, we want to make it look like it bounces a bit. And also when a planet appears, we want to give it a nice little bounce. In the animated library, this effect is called a spring effect. And take in mind that the animated library is built in ReactVR, so you just import animated from ReactVR and can use it normally. So let's look at the bounce effect. We click on a menu button, and the new 3D model appears with a small bounce, with a spring effect. So we covered most of the basics, most of the basic components that we have in ReactVR. And now we're going to talk about something that is a bit more advanced. If ReactVR doesn't support a feature that you need, you can build it yourself using native modules. A lot of stuff that exists in Three.js has not yet been implemented in ReactVR. For example, there are dozens of geometries in Three.js, of which only a sphere, a cylinder, and a box exist in ReactVR. For example, this tetrahedron geometry is supported in Three.js, but not in ReactVR. So let's create a native module. Let's extend it for React. I need to do two things. First, I create a module, and in its constructor, I receive the Three.js scene. From this point, the Three.js scene is open to me, and I can manipulate it easily. The rows within the add function are all Three.js coding. I define a tetrahedron geometry, a mesh Lambert material, and a new mesh that I'm adding to the actual Three.js scene. The second thing I need to do is go back to my client.js file and place my native module in the native modules array. I also make sure that my module is rendered on each frame of the Three.js rendering loop, or the animate loop. So here is my tetrahedron geometry in ReactVR, and using simple mathematics, I will use these tetrahedrons as asteroids, and they will orbit the 3D models. So here is the final application. We are inside a Pano component where we loaded an image of stars. We see the header with two texts and a 3D model in front of us. The 3D model is surrounded by asteroids. We created them using native modules. And on our right, we can see a menu. We can switch between the planets. There is a bounce effect both to the menu and to the 3D model. And you can see that both the additional information view and the navigation menu, those views have a billboarding property that is on, and as a result, they are always facing us. Now that you are familiar with ReactVR's components, I want to talk about different concepts about how to create a virtual reality tool. Some of the world's most popular brands have already adopted virtual reality to create virtual experiences to their customers. For example, hotel chain Marriott uses VR to teleport people to various branches around the country. And another example is car manufacturer Volvo. Volvo allows a potential customer to take virtual reality test drives. So one way to do so is using the video panel component, a component that allows us to load 360 degrees videos. As the video is being played, the user is seeing exactly what the director saw when filming. The other option would be to load a panel component, or again, a video panel component, and to predefine a set of hotspots, areas that users can interact with. A user activates a hotspot by gazing at it for a few seconds or pressing with a controller, at which point we are replacing the panoramic image source or the video source, and in that way we are teleporting the user to different locations, but actually is in the same place. As I mentioned before, ReactVR is based on Three.js, but only uses a portion of its properties. The main feature of ReactVR is the ability to create user interfaces in 3D. But when we want to develop some complex 3D experiences and dive deep into Three.js, we need to do some hacks or try to extend ReactVR to include those capabilities using native modules. In order to use different materials, shaders, lights, or to access the different properties of an object or manipulate it, we need to extend ReactVR. And as a result, we are always trying to keep both of the libraries in sync, and this is too difficult. So now I want to show you a different way. If we don't care if the user interface itself is in 2D, and we want to focus on the 3D, just on the 3D content, we can split the UI from the 3D engine. So all of the user interface is just React, a plain React, and all of the 3D content is Three.js. We are going to create a separate class for this. This class will control the Three.js scene, and the way to interact with it will be by calling the class methods directly, or if you are using Mobix or Redux, you can find a better way to do it. If you're using Redux, you can create a middleware, for example. So let's take a look at such a class and learn how to initialize a basic Three.js scene. So here in the init function, we are getting a reference to an element that will hold the Three.js canvas. We are creating a new perspective camera and a WebGL renderer. Then we are defining the orbit controls that gives us the ability to move around the 3D scene using our mouse. And we are calling the animate function. This will create a loop that causes the renderer to draw the scene every time the screen is refreshed. Typically, on a typical sprint, this means 60 times per second, 60 frames per second. So from this point, Three.js is fully integrated, and we can manipulate the scene easily and do a lot of stuff, do 3D experiences in web browser with a user interface that is in React. We're going to look at a few demos here. So we can use the following link using your mobile phones right now, bit.ly/3vr. Everything here is with React and Three.js. And you can check the demos on my GitHub, and you can use it. Just don't use the 3D models. So after splitting React and Three.js, we can use different loaders that we have in Three.js. Unlike ReactVR, which only supports the OBJ file format, now we can load different file types like Collada or C3D, or like this 3D model that comes with a built-in animation. And we can also use different materials and control their properties, such as metalness or roughness. We can load to the scene different lights that will affect our objects, such as ambient light or hemisphere light or directional light or spotlight, and many, many more. We also have helpers to see the lights, so we can move them around the scene. Now we can access the actual model and manipulate its geometry. The geometry is basically a set of points that define the model's vertices and faces. Here, with a simple for loop, I'm rotating each vertex according to its Y position. I just wrote a blog post about it in Medium, so you can see how to do this twist effect. To make the scene more realistic, we can add third-party libraries that simulate physics. Here I have used Oimo.js. There is also Canon.js and Physi.js. This will add to our scene gravity, collision detection, friction, the ability to add or to apply forces on different objects, and much, much more. Because we have access to the render loop, now it is easier to animate objects. So in this example, I'm getting input from the device's microphone, and I'm controlling the cube's Y position. I'm giving them a Y force according to your microphone average. You can use it. You need to enable it on your mobile phones, and then you can check this demo. It is also easier now to integrate different controllers that affect our scene, such as leap motion or vibe controllers. You can use them. There is a lot of third-party libraries right now. Here we can see leap motion with Three.js. But if we still want the VR experience, we need to add 3 things to our scene, just like ReactVR did. The first is the WebVR polyfill, a JavaScript implementation of the WebVR spec that will work on any platform. Second is the VR controls that are going to replace our orbit controls. This allows us to look around the scene using our headset and not our mouse. And lastly, the VR effect. This is going to replace our renderer, and this will give us the stereoscopic vision that I talked about in the beginning. I think that ReactVR is relatively new and lacks some of the core features of Three.js. For a very basic project that relies primarily on layout, I suggest using ReactVR. But for projects that use advanced features of Three.js, I would instead recommend integrating Three.js into React on your own. This will give you much more flexibility and access to the full range of features that the library offers. I hope that you've found this talk instructive, and I'll be more than happy if you will share your future experiences with me. Thank you very much, and enjoy the rest of the conference and the break, and I'm here for questions.